Algebra 1 skills number 11, solving linear equations. Okay, so we're going to start by looking at what solve means. And solve sometimes is misunderstood as simply finding the answer, but it's more specific than that. To solve is to find the value of a variable to make an equation or also an inequality true. Okay, so when we are given an equation with a variable, we want to find the value of that variable that makes that equation become a true equation. Because an equation doesn't have to necessarily be true based on what you put into it. We want to find something that does make it true. Now, a linear equation specifically is an equation where x is raised to the first power. Again, it's not in some kind of special symbol. It's not under a square root or an absolute value. And the steps are as follows. First, you want to distribute if necessary. Secondly, you want to combine like terms if necessary. Third, you want to get your variable to one side if necessary. And we're going to finish by saying solve the two steps. So it's understood or assumed that you probably know how to solve a two-step equation at this point. We're going to show you an example, but our steps for this slide will end there. So let's look at a two-step equation, something like this. 7x minus 9 equals 26. Notice it's an equation, you have an equals, it's linear, x is to the first power with no special symbol around it. So what we want to do is get x by itself. So here we're going to do the opposite operations to clear anything with the x. So the 7 and the 9's got to go. Now note here that there is no order of operations here. There's no rule that says you have to do one thing before the other necessarily. So we're going to actually add 9 first here. By adding 9, that clears that part away. And generally, you want to get rid of the thing fathers from the x first. So negative 9 plus 9 is 0. 26 plus 9 is 35. So I don't bother writing the 0. And I've successfully got rid of the 9. Now I want to get rid of the 7, so I do the opposite operation. 7 times x, well, the opposite of that will be divided by. So I'm going to divide both sides by 7. And note that whatever I do to one side of the equation, you've already learned you must do to the other. So I divide by 7 on both sides. 7 divided by 7 is 1, but it's not necessary to write the 1 here because 1 times x is just x. 35 divided by 7 is 5. So that 5 is the value of the variable that makes the equation true, x equals 5. A second example, this time we do have a distributive property. So remember the steps here. If you can distribute, you want to do that first. So I do that. 5 times x is 5x. 5 times negative 3 is negative 15. The second step was to combine like terms. So I'm going to combine the like terms. Now, when we say that, we mean like terms on the same side. Okay, don't try to mess with terms that are on opposite sides quite yet. 5x plus 2x is 7x. I just keep the negative 15. I keep the 55. And notice here that the get x to one side step is not necessary. So we're down to a two-step again. We're down basically to example 1. Again, here's x. Let's get rid of 15 first. 55 plus 15 is 70. And let's divide by 7 like before. And x is 10. So 10 is the value of the variable that makes the equation true here. This third example will have a little bit of everything. So again, distribute. 8 times x is 8x. 8 times negative 2 is negative 16. Combine like terms. 8 plus 6 is 14. Notice here we have x's on each side. So this is the point where we want to get the x's to one side. Now what I'd like to do is get the smaller x over to the larger one. I don't care if it goes left or right. Some people prefer to go one way. But I think it's easier to get the smaller x over to the bigger x. Okay, so if I subtract 7x from both sides, I'm going to end up with 7x minus 16 is equal to negative 9. Not just 7's in these examples, that's just coincidental. But again, we're down to a two-step equation. So I'm going to take that same equation and like before, add 16 and divide by 7, so x is equal to 1. Now there are cases where you have special things happen. So an example like this, very simple looking example, 2x plus 7 equals 2x. Now here, it's important to note that we don't want to ever empty out a side with linear equations. I would not want to subtract that 2x. I would want to subtract that one instead. It's going to look the same regardless. Here we are immediately to the step get x's to one side because you can't distribute here. There's nowhere to combine like terms. So get x's to one side. That requires you to subtract the 2x. Okay, so these 2x's cancel. Now these 2x's also cancel, but I can't leave a side completely void. So I need to put a 0 there. But notice what we have. We have 7 equals 0, which is truly not true. Or which is clearly rather not true. So in this event, no matter what I put in for x, you'll always end up with a false statement. So remember what solve means. Solve means find the value of the variable that makes it true. Well, you can't. There is no such value here. So if the x's cancel each other out and you're left with a false statement, you're going to say no solution for that one. A fifth example, again, distribute. So I distribute on each side here, 2x minus 18 and 9x minus 18. Okay, combine like terms. So notice the sides are identical. And when I try to get 9x away, just trying to get one to the other, they cancel each other. This time I'm left with a true statement. So in this example, whatever I put in for x, it's going to work every time. Okay, if I put in x over here, wherever I put in for x on one side, you can see it better on this line. It's going to give you the same things I put in for x over here. So everything is a solution here. So we'd say infinitely many solutions.